just need to go back and correct a mistake. Got this big hole here, which is no good for our sim. You know, because we're not going to get that detailed fracture up there. And I realize it's in this scatter, right? So we just need to basically raise up the relaxed iterations here. Unfortunately, it does mean we'll have to go run through this again. But none of it was too long. And again, thankfully, it's all procedural up until now, which is always a good thing. Okay, that's that fracture done, and we'll have to run through this again and just to save that cache again. There we go. Okay, and then just save that to disk, and then back out here. There we go. So we've got a couple of small holes there, but that's fine. You know, the idea is we're going to be breaking these down into pieces that small anyway, so we don't need to stress about that. So let's go to fracture these pieces down as well. So I'm going to measure them. I'm going to do this by volume. Seems a bit more, well, I don't know, you could do either. You know, the area will be the kind of surface area, and volume will be the volume. You know, there's no other way to say that really. But we do want to do per piece. And we'll use the name attributes. Okay, just measure them out. And then I'm going to be splitting big and small here. Going to be doing that a few times actually. Lots of splits, lots of measuring. Because, you know, we want as much detail as we need in certain areas, and you know, this sim could get very heavy if we just fractured, you know, the first boolean here. If we just did this fracture with loads and loads of detail, it would just be unworkable. We wouldn't be able to iterate on the simulations, right? So yeah, we got the volume. We previously in the course we were using the area. Now it's at volume. Okay, and then I'm going to set this to bigger than 30. Right, so just to get a sense of the difference in piece size there, these I'm looking at, you know, these kind of veins, I suppose, between the big chunks, and these are the big chunks themselves, right? So I'm going to say split big pieces there. And let's go ahead and look at fracturing these big pieces. So I'm going to set a for each named primitive, iterate over each of these pieces one by one. So we were using spheres earlier on, which is great. I'm going to do this bit with grids. The benefit with spheres, I suppose, is that you're not going to get any piece of the cutting geometry ending inside your other geometry. With grids, you just have to make them really big. And here we got, you know, we're going over each piece, so we don't need like super big grids, basically. I don't know, it's just a different way of doing it, to be honest. Right, so I'm going to scatter a few points onto this. I'm going to do this by density, and I decided on a value of 0.03. Okay, so, as we're iterating over the pieces, you don't want to have force total count, because we do, even though we did split our big pieces, there is a variation in size, so you know, it could look weird. You know, 5 points on one piece will be much different to 5 points on another piece. So we want to randomize the orientation, right? Let's make the grid first so we can see what we're doing, and copy to points. So the geometry in there, points in here, right? So we got, they are not random, but now they're following the normal of the geometry that they were sat on. Yeah, you can see we got normals there, right? I think if we delete them, yeah, you see that goes. Okay, but we'll keep them just in case. But what we do want to do is use the orient, right? So I'm going to use the attribute randomize, drop that down here. We don't want to randomize the color. We want to randomize the orient attribute. Okay, and I'm going to set this to direction or orientation. This is a quaternion, so we need four dimensions. Yeah. Okay, so getting that, we need to make this grid bigger, as I said. Okay, just to be sure that it never ends on the inside of one of the pieces, so that should be fine. We can check to get a sense of those piece size. You know, these grids are going to be much bigger than any of those pieces in there. Okay, and then we want to give it some, let's get rid of that. Obviously we need some resolution here, so we do 100 by 100, turn off those normals, and get our friend the mountaintop. Okay, so I'm just going to leave that at defaults, and then get a run a Boolean fracture on this. There we go. Okay, so just breaking those pieces down a bit. I don't in my test I didn't end up using the constraints here, but we'll save them out because it can be nice to do that. Let's give this a different name. The other one we called, I think we call these big, right? So fracture big, let's call this fracture medium. Because these are the final piece sizes now, right? Yeah, so we'll call that fracture medium, if I spelled that right, I'm not sure. Okay, so to get the constraints, we need a IBD pack. Plug that in there, and then IBD unpack. So before we visualize, you know, because that's going to run through, I'm just going to save this, plug that in there, just let that run through. There we go. And we can exploded view, just take a look at this. Okay, looks pretty good. I feel like we're getting, oh, we need to append this, that's why, yeah, sorry. So changes to append, and then we'll get new names. Here we got repeated name attributes there. There we go, so that looks right now. Okay, there you can see they're all spread out equally. And again, we've got nice looking pieces. Okay, so let's cache this. I'll cache it above here. File cache. Running through the that again, that's annoying. Okay, so I'm going to set this to save save current frame, and again into geo, and then we're going to say fracture medium. There, save that, and load from disk, save that, and load from disk, and there we have it. So next we can move on to the small pieces here.